This is a summary of the discipline of biomedical engineering, and you can think of a definition of biomedical engineering as the application of engineering principles to healthcare. Okay, that's a short and very broad definition. And so, as you can imagine, this is a very broad area. For one thing, this is the one area of engineering that isn't defined by sort of the techniques you use. It's just defined by what you use those techniques for. And so every different type of engineering is used inside biomedical engineering. There are people who focus more on electrical engineering stuff, focus more on chemical engineering stuff, mechanical engineering stuff. So majoring in biomedical engineering sort of necessarily means a little bit less deep and a little bit more broad study of engineering disciplines in undergraduate. The core sub areas of biomedical engineering are bioinformatics, that's using computer techniques to interpret and understand biological signals. As you can imagine, that's tends to be sort of use techniques of computer science more than other disciplines, more than other sub areas. Biomechanics, which is the area that I always studied. This has to do with measuring forces and deformations of biological systems. This is most closely related to mechanical engineering. Third is biomaterials. This is an area that the U of Minnesota is especially known for. This is the study of the interface between artificial tissue and living tissue. And this uses a lot of biology and a lot of chemistry. Fourth is biomedical optics, which uses optics for measurements. This is related to electrical engineering mostly. Then there's tissue engineering, which is largely related to building artificial tissues. And this can connect mechanical engineering type techniques with close study of biology and chemistry. Sixth is instrumentation. And this is closely related to electrical engineering. And then the last one that I'm going to list is medical devices. And medical devices is a very important area in the Twin Cities because we're a major hub, one of the few most important hubs in medical device industry in the world. There are a lot of big companies that are centered in the Twin Cities. If you're going to study biomedical engineering, a likely curriculum would start with, similar math to the other things, the other branches of engineering. You would have to take the whole calculus sequence. You'd have to take differential equations. and you'd have to take some statistics. For your science classes, you'd have to take physics and chemistry, just like in other disciplines. Although you'd have to take a bit more chemistry than you would in some other areas. And then there'd be a pretty big focus on physiology classes that you largely wouldn't have to take in other areas of engineering. Then once you're done with your math and science background, you'd take a class in biomechanics. You would likely take a class in medical instrumentation. And then, depending on where you go, there might be some other core requirements, but largely at this point, you would just go on to, that's supposed to be an and sign, lots of tech electives. And that's because if you major in biomedical engineering, you're likely going to have to pick a concentration and focus quite a bit on your concentration. There are two important things about biomedical engineering that I want to bring up. So I'll call this two important facts about biomedical engineering. The first one is, not everybody who gets an engineering degree ends up working in engineering. Engineering is actually a very flexible degree that puts you in a good position to go to law school, to go to business school, and a lot of engineering majors end up going to medical school. If you're interested in going to medical school, maybe you don't necessarily know that you're going to go to medical school, but you think that might be a possibility. Biomedical engineering is a great choice. So this is a good choice. And I'm going to put in parentheses with chemical engineering. That really would be the other good choice for someone who thinks this might be a possibility. And it's a good choice because there are a lot of requirements for classes to go to medical school. And majoring in biomedical engineering allows you to satisfy your major requirements at the same time that you take the chemistry and biology classes that are required for applying to medical school. So one reason somebody who is interested in medical school might consider biomedical engineering as a major is they think like, okay, I think I might want to go to medical school, but I also think there's a possibility that I won't, and I want to have a degree where I can get a good job right out of college if I don't end up going to medical school. And biomedical engineering is an area where you could satisfy those requirements, but also if you choose not to go to medical school, there are a lot of job opportunities. The second important thing about biomedical engineering is Twin Cities specific. The Twin Cities are a major hub for biomedical industry. And so, although you'll see that there aren't a ton of people nationwide working in biomedical engineering, in the U.S. In the Twin Cities, there's a big fraction of that. The big companies in the Twin Cities are Medtronic, the oddly named Boston Scientific, 3M does a lot of medical research, and then, there are some other bigger ones, and then there are a lot of smaller ones that have been spun off by former employees at these companies. And so the Twin Cities are a great place to be if you're thinking of trying to find a job in biomedical engineering. Occupational information. Like the other things, the other disciplines in engineering, I'm going to talk about 2023 results. The median, sorry, not the average, the median salary, meaning half of the people working in biomedical engineering make more than this and half make below it, is a little over $100,000. There are 19,700 people working in biomedical engineering in the US. And there's an expected 7% growth in the near future, which is faster than the average for all industries. And then last, what about the work environment? Well, this is an area where there's a pretty good variation in work environments available. So I'll just say various work environments. My PhD is in engineering mechanics, but I have a master's degree in biomedical engineering. And after I finished my master's degree, I worked for 3 years in a lab in a children's hospital in Birmingham, Alabama. And, when I was doing that job, I did some clinical work with patients. I observed surgeries. I worked with doctors. I worked a little bit in an office, a lot of programming. And so this is an area where you don't necessarily have to just be tied to an office job.